here, so you only have to keep one screen on. All right. In yesterday's review, we talked about how to split your screen into two. So it was Alt plus the bracket key on a Chromebook. Otherwise, if you could put me on two screens, great. And what I want to talk about is this is actually from week 3, day 5. Attached code showing if statements. Now I jumped right in and let's see, we got 41, 42% of the students got something turned in. And this is if statements. So let's do a quick review on if statements. All right. If statements. I'm going to ask some questions here. Start a poll. All right. Don't answer yet because I didn't actually. That's funny. I didn't actually put that poll. Forget sometimes when I do this how it's supposed to work. There we go. Start a poll. Custom poll. There we go. First thing we're going to say is it's going to be like a quiz almost. And I'm doing this on the other screen, so all right. I'm going to start the poll. I'd like you to select the most correct response. All right. So there's a variety of things that you're going to see over here. I'm trying to figure out if students can discern which is the most correct response. I bring up my notes here. I got them in here, maybe. Vocabulary types of data. There we go. All right, we're almost done. So I see 2 students join with headphones only, and so you can actually change that so you can join with audio, and then if you want to speak up, you can. So it's Alt-J, and then you can Alt-M to mute it. Great. So I'm going to publish the results here. Let me get to a whiteboard view so that you can actually see what's going on here. Stop sharing the screen for a minute. And so the question here, and I'm recording it on this side, so that's good. That will show up there, is which is the most, oh, once again, my fingers are off. And let's see if I publish these. All right. The one that is most correct, so let's review a couple of things about if statements. An if statement starts out with the reserved word if. Now, all of the examples I gave you were properly cased. So a mistake might be if you capitalized one of those. The next thing is going to be a condition, and conditions are going to return what kind of value? Can I return an int from an if statement? You can open your mic and tell me yes or no. Or you can type it in chat. Can I return, what kind of value can I return from an if statement, or does get returned from an if statement? Does anybody know? If I didn't cover this, I can talk about it. You know what? I will accept int because it's going to be true or false, or yes or no, 0 or 1. Perfectly fine. It is technically going to be described as a Boolean, but Booleans in integers, they actually kind of convert to each other very automatically. So as a quick review, remember we looked at that light switch, and the light switch, I should just show myself here so you can kind of see what I'm doing. So the light switch that we talked about had the up for 1 and down is 0. So 1 and 0, 1 is true and 0 is false. So I'll accept either one of those answers. It was not really a trick question. I just wanted to talk. I wanted it to use it as a lead-in. Now the thing that goes in the middle is a condition that's going to be true or false. And a couple of things about the examples I put up here. The condition that goes in the middle is going to evaluate to true or false. So if you have a condition in here, and if you said if true, it would always be true. If you had if 1, it would always be true. Similarly, and well, it syntactically works, it doesn't make a lot of sense to ask a question like, if something's true, that's what you're going to do. Usually you're using some type of a condition to compare two values. So the next thing I wanted to remind everybody is that when you go to build a condition, you should have the literal value on the left. So a literal value is one that is going to literally not change. If anyone's ever watched Parks and Rec, there was a character that used the word literally. He probably overused it. And the literal value that's inside of it should be on which side? It should be on the middle, on the right. Where should the literal be? On the left. Literal on the left. That kind of has, yep, exactly. So if you used an example where you had the word ammo on the left, ammo is actually a variable. So a variable is something that you tell it what type of data it is, you give it a name, and then you should assign a value into it initially. So when I say a variable type, we're going to talk about that in a minute, and let me switch over to my screen here. I'm going to share my screen. There are different types of data that you can use in C++, actually in most all programming languages. Something that's kind of unique to C++ is it's what we call explicitly typed. You cannot just start to use a type of data and not worry about what type of data it is. There are some that actually will, just fixing my error messages here. There we go. All right. There are some that will actually figure it out. Now, I'm not going to read this to you, but I'm going to basically give you the idea that in real life, when we go to deal with things, we're going to deal with them differently. And if I had, for example, somewhere in the room, I had a pile of watermelons, and I also had a pile of leaves, and I had a big pile of ants, and I wanted to move these things from one part of the room to the other. Now, I could take the rake, and I could move the leaves with the rake. But if I tried to use the rake to move the watermelons, it wouldn't go so well. And if I tried to move the ants with the rake, I'm not sure how well that's going to really work. Unless you don't care about the ants and you don't care about how long it takes you. There's better ways to move things around. And so we know that by assessing what's going on in real life. Now, the way a computer needs to know what's going on is it needs to know what type of data it's going to handle. So before you actually start to work with it, you need to tell the computer what type of data it is. It's going to store it differently, and it's going to move it around differently, and it's going to compare it differently. So there's probably a pretty good Minecraft reference to the crafting table with primitives. But the basic idea that I want you to understand is that there are primitive data types, and they're built into C++. And so these are the types of data, and we haven't used them all yet. But the type that's returned from a true and false or an if statement is going to be a Boolean value. Boolean values, as I just reviewed, could be one of two different values. They also take up the smallest amount of memory in a computer. It's just one off-on switch. It's called a bit. So if you have a 64-bit computer, you are actually using 64 individual zeros or ones to hold any basically it's the basic building block of memory. If you have a 32-bit computer, you've got 32 off-on switches, 16, 8, etc. So I have worked on 8-bit processors before. Memory gets really tight. You can't hold very large values, and you have to be very selective in how much memory you use. And so a Boolean data value is going to be a safe way to use a small amount of memory. So if you're programming on a device And some of the work I've done in the past works with like HVAC systems, moving air around, alarm systems. And some of those don't have a lot of memory. They might be a switch next to a fan that opens and closes a damper. And there's not a lot of memory in a little device like that. So you got to be very selective. So Boolean logic is something we talked a little bit about. Now a character is exactly that. It's one character. So it's your first initial, last initial, the letter Y, the letter N. We talked about an integer. The way to remember that is indicates no tenths. It's a whole number. It's a real number. Now there's some additional ones, and the water's not very deep. As you can see, we're already about halfway through the list. We have, if you can't use a whole number, and if you're going to use, for example, an average, you might want to have a decimal place in there, and you can use a floating point. Floating point values, kind of like what I talked about with Boolean before, they're of a set size. And so to make sure that you actually have enough space for a larger number, it's pretty common, especially with currency, to move to something that is actually larger. Could be a double floating point. And the difference here between a float and a double is it has twice as much precision. That doesn't necessarily mean larger. It means there could be more positions after the decimal place, not just before. So when you need to be precise, doubles are better than floats. This is a special word. We've used it before. Void means without value or empty. And we have something called a wide character. We'll get into that later. It's considered a primitive, but it's not something we're going to use in our curriculum. And then I got some extra characters from my word template that I don't need in here. So the types of data are important. And if you're going to compare these, you need to make sure your comparison statement is using something of the same type. So I want to kind of step back for a minute and talk about variables versus literals. And I want to work a little bit on the assignment operator. So I'm going to bring up the online GDB, and I'll do that here where it knows who I am. Get this out of here. I think I can get it out of there. I got two things sharing my screen right now. By the way, reality check. Am I lagging when I do it this way? Because I can't tell what it looks like on your end. Is my screen lagging bad, or is it tolerable? You can either talk or type a bit. All right. So it's not crucial that you see what I'm saying. What I'll do is I'll make myself smaller, and maybe that will be less of an issue for you. Jump in here for a minute. So if you already have another window open with the online GDB, that's great. If you don't, I would go ahead and do it. And get rid of this. Remember, when you come in here, you can start a new project by clicking on this button. And once that's open, you can kind of get it out of the way. In the upper corner over here, make sure that you're working on C++ as the programming language. And as a general principle, I would always run and make sure that this works for you first. It should say hello world and give you a 0 for your output. Everybody kind of caught up with me? In this instance, I'm actually going to delete all of the comments at the top just to make it small and get rid of any blank lines so we can really focus on this idea of data types. So printf is printing out a literal. It's a literal value that's within quotes. It doesn't change when it's set up that way. If I wanted to have a variable that was going to show up, I'd have to first declare a variable. So variables sit in memory, and you need to tell it what type of data. We just went over what types are. You need to give it a name. The name of your variable has to follow certain rules. It can't be a reserved word. It can't have any spaces in it. It can't have any punctuation in it. So you could use a simple character like X or A or B, and you're going to be using some of those today when we get into our in-class activity. But what I want you to understand is that the type and the name are, if I do that and end it with a semicolon, that would be called a declaration. Now all it's doing is it's telling the computer that I want to save a bit of memory to hold something. And that would be a valid declaration. So now I've got it declared. Now, I don't know what's in memory right now. Here we go. It's more proper to put in a value as well, because C++ might, you're just allocating a piece of memory that might have an old value in it. And we would call that a garbage value. And you don't want to process garbage values. You want to know what's in there. So a better format, and I'm going to set up a second one. I'm just going to use a number at the end to differentiate, is to assign a value into it. And so if you're going to assign a value into it like so, it is a declaration and initialization. So if I declare and initialize it, I now know what the value is within it. So we can print out this value two different ways. Now I'm going to pick a different value here. I'm going to go with 65, and you'll see why in a minute. Because what I'm going to do is I'm going to print these values out. I'm going to say printf, pardon me. And now instead of just using purely a literal, I'm going to put some special characters in the middle so that I can see what they are. I'm going to go down a line first. So how do I go down a line? Does anybody remember? I use an escape code sequence. So if I say like that, that goes down a line. Now what's the value in these variables? If I say the value in age is, now that's all in quotes. It's going to say the value in age is, but it doesn't show me the value. I'm going to put in a different version of this go forward. I'm going to use a tab character. I'm going to tab over. I'm going to give you some space so you can see what's going on. And I'm going to say in the format of an integer. Now, outside of the quotes, I'm also going to go down a line here. So the difference here is one's a tab character and one is a new line character. This will move the cursor over. This will move the cursor down a line. Now, outside of the quotes, but within the parentheses, I'm going to tell it to print age. Now, the value will show up in that line. And I need to end every C++ statement, practically speaking, with a semicolon. So if you're doing this at the same time, we're going to set up two different lines that print out basically age and age 2. So we're going to set this one up as age 2. And I'm hoping that by adding a tab character, these are pretty much going to line up. Now there's two different things happening here. The label that I've picked for printing this out happens to be the same as the variable name, but it doesn't have to be. So if I did this properly and I run it, we should see two different values show up. And of course I don't. This is an error message. You're going to see error messages. If I haven't talked about this, this is basically saying that I've got main. If I click on this, it should bring me right to the line. It's basically saying, I don't know what this big line here at the top is. I could comment it out, but I'm just going to delete it because I don't need any comments at the start. And same thing. So on that same line. So here we go. We got the value in age is 0. We're lucky there. That could have been some garbage value. The value in age 2 is 65. 65 is exactly the value I printed out. Now I'm also going to come back in here and I want to change this a little bit because in addition to the format of an integer, I can actually print it out in the format of a character. So I'm going to do a % like I did with integer, but I'm going to put C for character. What I'm going to do now is I'm going to use something like the Wonder Twins. Does anybody know the reference to the Wonder Twins? A bit? Okay. So the Wonder Twins were a cartoon where they could change their shape. They were shapeshifters.
We've got to stay awake, Jaina. Wonder Twin powers activate.
Shape of octopus.
Form of an ice unicycle. Come on, Jaina. It's up to us to stop those aliens.
So as weird as that was, he could become any form of water, and including an ice whatever, and she could become any kind of animal, if I remember correctly. I haven't watched it in years, but they were shapeshifters, and that gave them the ability to do all kinds. That was their superpower. Oh, I hope I didn't accidentally close my window out. Let's see if I can tab over to it. Find my online GDB. I may have closed my online GDB by accident. That's okay. Oh, there it is. Got it. All right. So now what I'm going to do is in the format of a character. Now this is a second parameter. Now this is an important idea. This is called positional importance. Now the first value that I put here, age, is going to show up in the first area where it says print in the format of. I've got another one here, this %C. And what I need to do is I need to actually provide what's going to print in this value here next in order. So what I'm going to do is I'm going to add a second value to show up in the second position. I'm going to actually print the same value twice. But it's going to print in a different format. So what I mean by that is first we're going to see the value 0 as an integer, then we're going to see it as a character.
9 o'clock a.m., 67 degrees Fahrenheit.
I'm also going to do the same thing on the second variable down here. Similarly, I need to change this line so that it knows in where it says $C what to print there. So I'm going to print age 2 in the format of a character. So let's try this version. Now, this is the line that gets printed as a result of this command line right here. When we print it as an integer, it is showing up as a 65. And when we print it as a character, we print it out as the letter A. So I'd like you to keep in mind, if A is 65, how could you convert that number value into a letter to match your first initial of your name? So you could do a little bit of math. I'm going to open up the calculator here. Just a standard calculator. And if A is 65, how would I get down to, I'll use J. Okay, so 65 is A. Now, how do I get to J? I got to go see A, B, C, D, E, F, G, H, I, J, K, L, J. So it looks to me like it's 11th. 65 plus 11. 76. So I might be off by 1 because I'm not the best at math impromptu when I'm in the middle of doing this. Didn't practice this. So let me try 76 here. See if I get in here and change this to 76. If I print it out now. Oh, I'm way off. I'm off by 2. Let me go back in here and make it a 74. I guess I should practice this so I look a little bit more learned and less random. There we go. So a J is a 74, which tells me that that value 74 is stored in memory anytime the letter J is used. So printing out in a different format doesn't work with everything, but it does work well with, for example, true and false or 0 and 1 in characters and integers work. That gives us a little bit of insight to what's getting stored in memory. Now, I'm going to go back to my calculator here because if you have a full-blown computer with you, not just a Chromebook, I want to bring up the calculator for a minute, and I'm going to show you a different view. So instead of doing a standard view here, I'm going to look at a programmer view. Now, a programmer view might be new to you. I'm going to make this a little bit larger so I can kind of just work with it. And one of the things I want you to see is that they actually have these different encodings down here. These are different number systems, and they're important to programmers because The way values are stored in memory is done with a different number system. Which one of these do we use in our daily lives? Can somebody just pop on their mic or type in and tell me, do we use HEX, DEC, OCT, or BIN? DEC. And why is it? What does DEC stand for? Does anybody have any ideas? Decimal, base 10. Great. We've talked about one other number system here. We've talked about binary. So you'll notice when I'm on binary, the only digits I can use are 1 and 0. I can't use a 2 because that's not available in the binary. If I go to decimal, that is the whole set of values here. Now there's one called octal. Notice the highest value is 7. And knowing what you know about OCT, like octopus, which we showed a minute ago, what is the base in OCT? Base 8. It's octal. Trivia question. Does anybody know why October is not the 8th month in the year? Romans. So those of you who don't know.
It's because, July and August named after Julius and Augustus Caesar, and Augustus added them because reorganizing the Roman calendar anyway.
Yep, that's it. It's because we use a Roman calendar, and Rome ruled the world for a long time. There's a lot of interesting history there. The size of the roads with the Roman chariots was standardized, which let them make a standard cart that wouldn't get stuck in the ruts, which became the same gauge for the train tracks. There's so many things we've inherited from the Romans, and two of them are months: July for Julius Caesar and August for Augustus Caesar. And they put them right in the middle of the nice time of the year so that it moved everything, the 9th, 10th, 11th. That's why December should be the 10th month. DEC would make a lot more sense. But things being as they are, this is what we deal with. But inside the computer, we use Octal. So I'm going to show you some very deep nerd humor. All right. This is something that computer programmers will appreciate if they're up on it. If you know somebody who's into computers, they would get this. And if they're not really into computers, but they think they are, they won't get it. So why did the programmer confuse Christmas with Halloween? Anybody know why? Somebody's guessing. Somebody probably Googled it. Here's why. Because of the number systems convert. So let's jump into the calculator again. And most people don't walk around thinking about this. But if I go into Oct, what day is Halloween on? October 31st. Now, if I convert that to a decimal value, it's decimal 25. So, in number systems, octal 31 is equal to decimal 25. Because the number systems are different, what I'm really saying here is I'm saying 3/8 and 1/1. So 3/8 is 24, and one more makes it 25. Now we can also convert that into binary. Now what is it in binary? I was becoming a computer programmer. I had to learn how to convert everything into binary by hand. I'm just going to show you down here. It says BIN. That's the binary value for decimal 25. So if I go back to decimal here, and I were to convert a decimal value of, let me clear out a memory here. I think escape will do that. a decimal value of 65, that's going to give me this binary representation right here. It's zeros and ones, and that is in binary. That's how you store the letter A. So you may have wondered, how is it when I touch keys on a keyboard, somehow it ends up being put into binary? And the answer is there is a standard that's used. And that's the only way that this is going to work, just like with the Roman, the axles and the wheel spacing having to be the same. Because otherwise, if your cart didn't match it and you went to go through a muddy rut that was made by Roman chariots, your axles would get broken. Those wooden axles would not put up with, the tracks being different. So they set the standard. So you can't write some random program that works in memory that doesn't use the standard that was set. So there's kind of I guess I could say an acronym. Yeah, there's an acronym that lets people know what it is that we're using. It's called the ASCII, ASCII, ASCII. So the ASCII codes are basically the codes that tell you what values show up as what characters. So if we looked in here and we found the ASCII value for 65, we'll notice that 65 lines up with the letter A. And if I had been smart and just looked in here, which is what I usually do if I need something, I could have figured out that my J is 74. Now, some of the characters out here will print differently on the screen. Let's see here if I can figure out. Oh, look at this. What's this 7? What do you think 7 would do? I'll try that. And I haven't tried it in this system before, but what if I put a 7 in there? Instead of 74, I'm going to change this to 7. I'm going to go ahead and try this. I don't know if you could hear that, but if you do it on yours, there's a little beep. Did you happen to hear the beep? If you've got the code, print out the value 7. It's called a bell sound. Now, once I knew how to make the machine make a beep sound, what I learned to do in college, and this is at a time when you needed to hand in a printed copy of your labs to the teacher at the end of the day. And what would happen is that the guy who's working in the lab was another college student, and he would just wait till there was a lot of paper, or it would run out of paper, and then he would go over and take all of the print jobs and start laying them out for people. So sometimes you had to wait, 40 minutes for your work, for your printout. So I played a little game. What I would do is I would send 7 bells and then my print job and then 7 bells. And then I'd go stand right by the guy with the printer. And what would happen is as they were sitting there doing whatever else, studying, the printer would make 7 beeps, my job would print, and then it would make 7 beeps again. The beeps would make them think, oh, something's wrong with the printer. They'd stand up and they'd walk over to the printer and they'd be looking at it trying to figure out why it beeped. And then I'd say, hey, do me a favor, grab that top print job. I need to give it to a teacher. Just making it sound like it was an important thing. They would grab the print job and hand it to me and I'd be gone. And that was because, it was kind of a bit of a hack, I knew how to make the sound of a bell or a beep come out of the printer by printing character string 7. So that's again some insight, because nerds, as they once said it in one of the early videos, they can be like, superpowers if you know how to use them, if you figure out how to hack, so to speak, in. Okay? Enough about that. Today, what I want to get into is functions. And the reason I backed up a little bit to talk about the types of data is I want to make sure you understand that just like a variable, one of the things you need to do about a function is you need to talk about what the return type is. So has anybody used a function before in C++? Raise your hand if you think you have. Actually, let me do it this way. I'm gonna launch a poll here. See if I can get control of my computer again. There we go. Get this out of the way. Let's do this. Do a yes/no poll. Have you ever used a function in C++ before? I'm going to stop sharing my screen for a minute so I can get to a whiteboard here. And the question we're asking is, have you ever used a C++ function before? All right. So overwhelmingly, people are saying no. Let me go back to my screen here for a minute. And let me explain something to you. A function starts out with, first thing it does is it tells you what the return type is. So a return type could be a type of data, or it could be the word void. So a type of data could be something like the word int. That's a type of data. The next thing you need is you need the name of a function. The name of a function can't be a reserved word, just like a variable. And then even if you're not going to pass anything into it, you need to have a set of parentheses that could hold values. And every body of a function needs to have a curly brace that opens and stops it. And if it has a return, then that return type must match the value that is returned. So when we use int main, we're using a function. So let me ask that question again. How many people here have used a function in C++ before? Got a few people that maybe are not sure or stepped away, and I'll publish these. So let me go back to my screen again, and let me just be explicit here, because I was just walking you up to this, but I'm going to clobber you over the head with it. Main is a function. So whenever you use int main, you are using a function, because it has all those values we've talked about. It has a return type. It has a name. It has the area for you to give it data if it needs it. It has a set of curly braces, and it has a return statement. So this is an example of a function. Okay, so let me come back in here, and let me ask you again. Have you ever used a function in C++ before? Ooh. So I see two people that are saying no so far. Have you ever run main before? Have you done a C++ program? If you have, then you've used main in a function. Main is a function. So everybody, is there any questions that you have for me? Because I'm trying to get you to understand that main is a function. So let me come out of polling. I'm not even going to publish those results. I'm just going to invite questions here. You can type in public chat. You can open up the mic. And I'm trying to figure out if you have what questions you have about a function. Any questions at all? Int is a type of data. That's a return type. It needs to have a name. Main is the name of the function. Then holder in case there is input. Okay, so when I say a type for a function, it's the type of data that gets returned. So let me show you a couple of examples. And I've got these out there for you to look at as well. But important thing about every other function besides main is every other function needs to be known in advance. So in a longer book, it may be divided into smaller sections, commonly referred to as chapters. And the chapters of a book are usually listed in something that's called a table of contents. So within a C++ program, you need to tell C++ that coming up later there's going to be something. All it is, it's called the prototype. That's the word I was looking for. It's the prototype of the function. So if I'm going to return a whole number at the end, it's going to be an integer value. If the job of it is to add two numbers up, you can give it a name that describes the function. And then there's kind of a sandwich. And then whenever you see these, you can kind of think like, if I was going to grab one of those Jimmy John's gargantuan sandwiches, I'd have to use two hands to pick it up because they got to come in a match set. Anything in the middle there is kind of going into the function. So to add two numbers, what do I have to bring in? If I say add up two numbers, what do you need to know? You need to know the two numbers. So let's say integer first number, and after that we'll put a comma to separate, saying here's more, and then another integer value called second number. Now this prototype is just kind of saying coming up later. Like if somebody's watching Nickelodeon and I just copied and pasted that. If you're watching, TV, they might say coming up later, SpongeBob, followed by more SpongeBob, followed by more SpongeBob. They're telling you what's coming up later. It's like a table of contents. It's like a list of function prototypes. It's letting C++ know, I'm going to give you the details later, but now just know something's coming up. So in this case, we've got the start of descriptions of three different functions. Now main is special. Main does not need to have a function prototype above it. Every other function does need to have it. So now that I've got these two things just kind of set up, I'm going to copy them from here and I'm going to go below main. Remember that main starts and ends where these curly braces are. And what I'm going to do now is collapse them by clicking on this little diamond there. Now you'll notice that the line number goes from 6 to 15, and you see this indication that there's something in the middle there. I can click again to open it up and look at the details. So it toggles off and on. It can be opened or collapsed. Down here on line 16, I'm going to paste what I just copied. And instead of having that semicolon at the end, I'm going to highlight it and replace that with an open curly brace. And inside of here is going to be the body or the commands that get done when you're running that function. So it's going to start here and it's going to end there. Similarly, this one, if I come down a line and open a curly brace, and there should be a closed curly brace as well. So the statements for them need to be in the middle. There's the main, and down here is the space for them. Now I want to run this for a minute and make sure I didn't introduce an error. So at the end of my, I've got an extra character there. I confused it because I had an extra character there. And also, it's having, I've got an extra close at the end. So what I just did is I thought to myself, this isn't recognizing the reserved words and changing the color of things like I would expect. So I just want to make sure I can compile it. All right. So just by setting this up with the description at the top called a prototype and the body holder down below, it still compiles, but it doesn't actually do anything. Now, how could I take two values in and then return the value that the two of them go in together? How could I do that? Anyone have any ideas? How do you add two numbers? Whenever you go to solve a problem with a computer, you need to know how to do it yourself first. You can't tell a computer, do me a favor, go invent life, and it's going to go invent life for you. It doesn't work that way. What computers are really good at doing is they are really good at doing exactly what you tell them to do very quickly. And so if I was going to tell a computer to add two numbers together, I have to understand, like, for example, if I take 7 plus 3, I know that's going to equal 10. Now, I don't want it to always work with those exact values, those literal values. So knowing algebra, which hopefully you do from coming in here, you might know x plus y is equal to sum. But remember Yoda talk. So we need to reorder this into a different order. And so what we're going to say is we're going to say that there's an integer value called sum, meaning the sum of two values. And into sum, we're going to assign the result of, and you can build it inside of parentheses so it's clear for you. You could say the first number, and then the operation to add, which is a plus sign. And that's going to end in a semicolon. So this is the code that you need to tell a computer to add two numbers together, right there. Now I need to put that into the function so the function knows what to do. Now I'll be candid. You don't really need to build a function just to add two numbers together. However, I want you to practice building functions that do a job. And this is the one we're going to work with. So let's take a look here in our code and let's get this going. So that add 'em up is going to actually, well, first we need a place to store it. So remember we talked about declaring and initializing a variable? What type of data should we use to add two numbers together to hold the result of two whole numbers? What type of number is 10 in our example? I'll give you some choices and you can use the start a poll here. So should we use all right. What type of data should we use to hold the result of two values? If you don't know, say I don't know. So we got one more person. I'm still giving them a time to wait. I mean, to respond. They may be AFK, so I'm going to go ahead and publish these results. So a lot of people said they don't know, and that's the most important thing. Now, in this case, you could use either an integer or you could use a float. So an integer would be the one that I would probably use for this if I know they're going to be whole numbers. You know, again, if you're working with lives or ammo, a lot of the concepts we're dealing with in games programming are whole numbers or real numbers. And so those would be appropriate. If you used a float can hold a whole number. It's okay. It's just using more memory than you have to, but it could be, you could have a reason for doing that. Anybody say anything else? I don't know. So let's talk again about what int stands for. Int tells you that you're going to it's going to take a whole number. So the way I remember it is it indicates no tenths. INT, an integer, whole number. It's like the number of cats in your house. 0, 1, 2, 3, but not like 3.7. That's 0.7 of a cat's got a problem, right? Especially if it's 3.1. That 0.1 of a cat has got a real problem. All right, hopefully nobody's dealing with that at home. So the point here is if I'm going to return a whole number, which is set up here, I'm waiting for the screen to come up. Here's the whole number. If that's what I'm going to be dealing with there, let me cursor highlight that. Highlight clicks. Focus mouse. There we go. Since I'm going to return an integer value here, what I want to do is I want to actually make sure that I set up a variable. I'm going to hold it, and I can assign that value to first number. When it highlights it, and now how do I add to? I add the operation. Using code completion, that line just kind of like flows right out of your hands. So now I've got a value stored in a variable called sum. So what I can do is return that value called sum. So this is what happens. Right now, this function's not being called. So let's compare this to Lightbot for a minute. Anyone did not do Lightbot, and because there's some people that haven't turned it in, I want to make sure that we go back to this for a minute. When you see this forward arrow in the light bulb, these are commands that the program is doing, that the Lightbot is following, right? When you see proc1 down here, this is a procedure. Now you'll notice in main, we have a main. When we're in main, we are actually calling P1. Whenever you see the word P1, the control, the next instruction occurs down here. And it will follow through these commands and then return right after it came where it came from. So P1 can be called multiple times. And so instead of having to have these 4 commands listed every time above, they're in a procedure, which is another way of basically grouping a bunch of commands. It would be a function. So here's a set of commands. They call it a procedure. C++ calls it a function. Lightbot's an example of the concepts of going through and doing some programming, but it's not programming in the same sense as C++. So now in order for me to do this add 'em up, I need to pass a number in, first number, and a number in called second number. So to get these 2 values in, I need to do that in what part of the program? Where do I actually do that? Thank you for setting me straight here. So someone just caught the fact that I have this under takeaway. What I'm going to do now is I'm going to copy this and I'm going to paste it up here. And the only difference I need from takeaway is I need to make that a subtraction. So that's a spoiler, that setting up more than one function, if they're very similar, can be as easy as copy and paste. Do you know in a lot of classes they say don't copy? In this class, as long as you understand what it does, copy as much as you can. If I give you a sample, start with that. Don't start with a blank piece of paper. Once you've built a program, you're never going to start with a blank program again unless you're a teacher and you're always restarting with a new project. You're going to reuse what you got working. That's how that happens in industry. All right. So the one part we're missing, if we look at that Lightbot again, is that call that says P1. So every function that's not main is going to show up 3 different times. Let me go back and stop sharing my screen for a minute and give you the concept first. I don't know if I have another slide. I do. All right. So above main, we need to have a prototype. That's like the table of contents. So we're going to have our prototype up here. And the prototype needs to say the return type, the name of them, and anything that comes in. Above here at the prototype level, you need to have a semicolon at the end. In main, somewhere, you need to have a function call. Now, a function call is going to bring a value back, and you can do something with it in this case. However, you don't need to say what the return type is in this instance. We're just calling it. So I give it the name, just like if I'm going to call someone and I go, Robert. Well, I just called your name. So Robert's like, what? Why are you calling my name? So if I said something like, Gavin, I'm going to give you two numbers. I want you to add them together. Okay, 3 and 7. What is it, Gavin? And then Gavin has to take those two numbers, add them together, and give me a result. He returned a value to me. Thank you, Gavin. So what I want you to know is that when you call it, you give it the name and you tell it any information. So the name of the function is add them up. I came up with that function name. It describes what they do. And I need to give it the two values, 7 and 3 in that instance. So what happens is it will call the function, and the value comes right back into main. Now below main, you're going to have the actual body. Now it's going to look just like above. It's going to have the same thing as the declaration above. In fact, I would copy this line so that it is exact, but there's no semicolon down here. Down here, we actually have the body. Instead of the semicolon, we've got the body that actually does what it's supposed to do. Now I can shorten this process up. I don't have to set up a memory location called sum or result and return that. I could just have a simple return line that says return, and then tell it take X and add it to Y and return that value. Now again, a function is not going to do one statement. This is just to get you to practice building functions. So what I'm going to do is I'm going to give you now some time to work with a sample program. And I'm going to show it to you. We're going to talk about it. It's got a copious amount of comments in it. And the reason I did that is I want you to really have everything I talked about within the sample code that I'm giving you. So this is throwaway work to me. I don't need to save this at all. So what I'm going to do is I'm going to start sharing my screen again. And I'd like you to follow along, and I'd like you to use the little sidebar over here within, sorry, I got something that's in the way. I'd like you to use the sidebar to bring this, this part open and go into the classroom. I don't need to save these at all. I can cancel that. Oh, well, I can leave. That's what I can do. There we go. So now you should be in the classroom, I hope. If I look in here, get back to my cursor. I've got 37 students enrolled. I'm going to grab an invitation here and copy this out because I don't see all of my students. And if you are in here, forgive me for doing this for a minute, but I've got 50 students in class and I only see 37 in here. So let me bring up an email and let everybody know that I need everyone in the online GDB class. If you are already in, great. Otherwise, use this link to add. There. Set up a distribution list for myself called 2020 plus plus. Oops. So that everybody will get this email. And to make it easy to see if you're in there or not, I should be able to see everybody's name. There we go. Do a copy and paste it in here. It won't be alphabetized, but most people are already in there. Okay? I'm going to send this out. You should get an email. And if you are already in, if you see your name there, you're good. Otherwise, please click on the link and get yourself set up in the class. So in the classroom, I do have an assignment or activity there for you called in-class activity function starting point for, and it's got today's date. So if you click here, let me do a preview. This is what it's going to look like to you. It says, using the sample provided and the instructions, modify the code to do the following. Rename the sample function so it describes the job it does. Big hint, it does add two numbers. So you can call it whatever you want. You could say sum, add, put them together. Give it a name. Give it a name that works. The next thing you're going to be doing in here is you're going to be using that as a model to actually do your add, subtract, multiply, and divide. So you're going to rename, you're going to set up functions, you're going to run sets of data described for your session. So what this is when you put together a program, in order to make sure it works, I'm going to tell you what data to use. And sometimes I might give you stuff that's going to cause the program to blow up. So watch for special words like save your work before you run the following data. Because, for example, if you tell a computer to divide by 0, it could cause a problem, and I don't want you to lose your work. Ask questions. Let me know what your error messages are. Save early, save often. You start bouncing around between tabs, and online GDB gets confused. And for some of you that are really on top of everything, and I'm talking to the people that have already turned this assignment in, I want you to add functions that would take in a variable and demonstrating the 3 ways to add one to the value and one for reducing the value. So you'll add a couple more functions if you've got the time. It's good practice for you. In the sample code here, if you run it, you're going to see that it doesn't just take 7 and 3 every time. What it's going to do, hopefully this will compile for us, is you should prompt the user. It should say, give me the first number, give me the second number, and then add them together. So every time you run it, it's not going to use the same values. It's going to use variables. It's taking this a little bit of time to compile. If this is giving you trouble, what you can do is you can copy all the text from here. So if you start at the top, go to the bottom, do a copy, and then we come back into here and we'll do a new project, highlight everything and paste it. Make sure we're in C++, which we are. So we're in C++. I pasted it in here. I'm going to hide the little sidebar and do a run. And then down below here, it should hopefully give us enter the first number, enter the second number, and then perform the process and show you the result. Now, to give you, that's interesting. So this, again, I think is because I'm bouncing around, but I still got it copied. If you get this error message, that's why I want you to make lots of backups. I'm just going to create a new project. Copy everything here, or I should say paste it in here. Just make a couple of changes to the code. Make sure I'm actually in this program here. So this is a function prototype at the top here. Talks about using A and B. Now the variable names don't have to be exact everywhere. I could pass in 2 numbers or 2 different variables. They just need to line up with these values, that is the type. You're going to build ones for subtract, multiply, divide, remainder. For remainder, you might have to do a little bit of research. See how far you get on this. Let's go ahead and run this. I'm having trouble with this. So I'm going to actually do this. I've got it copied. I'm going to actually relaunch the GDB. I jumped in new. I'm going to do a new project. I'm going to leave some lines in here. I'm just trying to experiment. I'm going to paste in my new lines and try to run it. There. Let's see here. Come down. Demonstration and sample of a function to modify. First number, well, let's use a different number like 25. Second number, 36. So now what it's doing is it's printing out. Oh, I keep getting a connection lost. Let me know if this is becoming problematic for you. I don't know if it's because we're all jumping on online GDB right now, or if there's a different issue going on. Same with you, huh? Okay. They might be having an issue on their end. Okay. Okay, well, that's good to know. It was working fine for me, see, Saturday and Sunday when I was doing this. So I don't know if, now it's possible that more people are using this as time goes on, kind of like when Zoom started crashing, right? The thing in Classroom, let me jump into Google Classroom. I can jump back to this. Leave this. Yeah, I agree. Week 4, day 1, Funk programming. Maybe I didn't put a due date in here. Oh, it says due date. So it should be under week 4, day 1, assignment B, in-class activity, programming functions to add, subtract, multiply, and divide. Here's the sample code. I put it up here as well for you. And here's the sets of data that I want you to run it with. You meant in GDB. Okay. So let me jump back into GDB here. And we go to Classroom. I'm in as a teacher, so it might be a little bit different view if I click on the class. This one. It says published. So normally it would say publish if it hasn't been published yet. So not sure why it's not coming up for you. Okay. Thanks, Chris. So some people are seeing it. If you need to, you can copy it from Google Classroom into a new project. For some reason, I think if I leave the first lines in there, it seems to work better. Paste this in here and do a run. It keeps the connection to the server. All right. I'm going to do a poll here. Has anyone gotten this to work, yes or no? Like they can put the sample code in and run it. So here we go, yes or no. Nobody has, okay. Oh, one person has.
Yeah, I got it to work.
2 people have. Okay. Well, if it's worked for 2 people, then we should probably keep trying. If it hadn't worked for anybody, I'd say we have to try something different. I'm going to go AFK for a couple minutes because I want to check on something and see if anybody else in the building's having an issue with connection to a similar service. But I will be back. I'm just going to officially set my status here to AFK so you know. If you want to stand up and go stretch your legs, etc., I'll reconnect back here probably 5 minutes or so. I just need a couple minutes to go take care of something. I'm going to pause the recording here, and I'll stop sharing my screen there.